All right. So hello everyone. This is Harshith from DSAI IIT Roorkee, and this is my CWS project, which is technically a market-based analysis which I did using the C++ language in the VS Code editor. Right. So technically, in this video, what we're going to do is we'll uh, look into look into a code that's developed using the a priori algorithm, right? We'll discuss about a priori algorithm later, but first let me tell you what's the basic idea behind this project, right? So first we're going to first let's start, right? So what's the goal? Okay, so when we purchase items in a supermarket or anywhere, so what we need to do as a businessman is we need to find hidden patterns, right? So we need to find hidden patterns in which the customer purchases objects, so that we can apply better logics in which we can apply in the supermarket, such that the customer, like, suppose if we have bread, which there in this example, like if a person buys bread, so there is a possibility that he might buy milk due to the statistical data which the supermarket gets due to selling some objects, right? So what we do is we place bread near milk. Otherwise, something similar logics. So technically, in this video, we are going to discuss this and how we're going to do this using the C++ code, and we are going to, like, it's going to be helpful for the supermarket owners, or like what we've done is a basic idea, but if we implement it, this is going to help in many things. Like there are also very big MNCs like Amazon and Netflix. Even they use recommendation systems, which is nothing but the logic is same. The logic is same, but the implementation is in a different way. Like what they do is they do it in online websites and stuff, and what I'm talking about is in the offline stores, right? So yeah, this is the idea. We need to find hidden patterns in which customers buy things. Right. Let's move on. Right. So how do we do this? No, the simple basic idea is, like, if you go from the basics, it's nothing but math. Okay. What we're going to do is we are going to apply some very basic, simple association rules, and then find out how we're going to do this. Right. So the primary goal is to discover an association rule, a simple if-then statement predicting customer behavior. Yeah, this is what we're talking about. And there's an example. If a customer buys bread, then he might likely buy milk too. Yeah. Then there's the targeted marketing, because obviously, because if a person buys milk, they're targeting him and predicting that he might buy bread, otherwise he might buy butter or he might buy egg or something like that. Then we've discussed the store layout optimization, like near bread, if we place milk, there's more possibility. And yeah, there's this product bundling too, in which we can make combo offers. Like if you buy milk, butter, and bread together, you might get a certain percent discount or something like this. So all this we are going to do by taking in the raw data and just uh, s- placing them in statistic data and making a better version of it just for us to know easily through the code, and we'll just do combo offers and stuff. Right, so let's get into it. Let's get into the coding now. But before that, let's understand what is a priori algorithm and how do we implement it, right? So for applying the a priori algorithm, these are the very basic two terms that we require. One of them is support. Support. So what is support? Support is the percentage of total transactions in which an item set appears. Right. So if you're in a supermarket, it's if we sit and write the code such that each and every object comes in that code, and we see what every person is buying for a certain object is buying another thing. So it's going to make unlimited combinations, which is like computationally impossible to calculate. So what you're going to do is you're going to set a minimum support. So what is support? Support is like, suppose if we technically we are just going to choose the products which most of the customers are buying. We are going to set a minimum, like, percentage data. We're going to set a minimum percentage of which the customer has to buy, and That's the support. And next, confidence. Confidence is the likelihood that item B is also bought when item A is purchased. And this is the mathematical formula you can see. Okay. So confidence is something that if a person buys, we put in the raw data, and through this formula we can find if a person buys butter, then from the information of the combinations of the data that we have given, we can find out that what percentage of people who bought butter are likely to buy bread. So this is a very helpful term. So okay, let's go. So okay, all right. So this is the order in which we are going to, you know, technically code. This is the basic logic behind a priori, behind coding. So right. First, we're going to take the input data. We are going to read transactions, minimum support, and confidence thresholds. This we are going to take an input by the like supermarket owner or whatever whosoever is going to use this. Then we are going to apply the a priori algorithm to identify all frequently occurring item combinations. Then we are going to derive association rules and apply the math which we've just discussed, and it's just easy coding. And excuse me, right. So then we'll display the final report. All right. Right. So let us see what is a priori algorithm and how it works and how it functions. And later we'll get into this code. Okay. So first, here we've got a sample data for better understanding. And in the example, the minimum support has been set to 2. Okay, so the minimum support for it to proceed to the next step, otherwise to comment into the recommendation system that we have made in the output, the minimum support has to be 2. Okay, so there are basically 3 steps in which we do this. So first step, in the first step, what we do is for every single item. Like in this, we have apple pie, bread, cake, donut. Yeah, that's it, I guess. And for these 4 items, we check individually that for each item if the minimum support has been met or not. So first we do that in the first step. Then we have the second step. We technically just do pairs, and we we do pairs, and as you can see here it's written apple pie and bread. It is being kept and it's going to the next step because its count has been 2, which is in the T1 and in the T2. You can clearly see apple pie, apple and bread. And in the count, in the next step, you can see even apple pie and donut has been considered because in this data there are 4 terms. So he has to consider everything. So apple pie donut he has considered. But there's no combination with apple pie and donut. So we can say that a customer who's buying apple pie and donut together is only one guy. This is T3 person. Okay. So it has been dropped here. So the next step, this is the pruning step. This is like the most crucial step in a priori algorithm, and is technically the whole thing which defines a priori, right? Because if there's not this step, and if we sit and if we do the combination for each and everything, and if we check the per confidence percentage, support percentage for each and every combination, and we calculate, and then if we segregate, like it's also possible. It's the brute force method, but if we do it, it's going to be computationally impossible. And if I just give you a 10 to 20 items, the data set is going to it's going to be too much, and it's going to be computationally very hard to calculate, right? So that's the use of this a priori algorithm. That's where it comes into action. So okay, so first let's understand what is this pruning step. So in this pruning step, what it basically does is like here, as you can see, first for count 2, we have an example apple pie and bread. So it has gone to the step 2. And even T1 guy, you can see apple pie and cake. And there's another combination apple pie and cake. So even this will go forward because the minimum support has been met. Right. So what happens in the step 3 is like, for basic understanding, let us call this a single terms which has been passed. We'll call it L1, and for these double terms, this combos, let us call it L2, for better explanation and better understanding of uh, the a priori algorithm. So there are 3 terms in this set. So this is technically L3. So what happens is the items qualified. What happens is the combos are made again, and in the L3 combos, apple pie, bread, cake is made. So what happens is in the L3, the subsets are again made, and it is checked if the same subsets are present in L2. Like if there are three items, if there are three items, the subsets are made only into 3 minus 1, which is 2. We're not going to go like if there are three ways checking for every single one because we have already done it in the first step, so it's going to make no sense. So what we're going to do is just a step behind. We'll make subsets and we'll check if it's there. Suppose if you're doing in the LN set, so we'll just check if those items or subsets are there in the LN minus one too, right? So let us see for this example. For better understanding because in this technical terms it's a little hard to understand, right? So we made a combo by adding the terms in L2, which was apple pie and bread qualified and apple pie and cake to qualified. So we'll combine them to make apple pie, bread and cake. So this has got to step 3. But in step 3, again I told you we make subsets and check if it's there in L2 because okay. So the subsets first one is apple pie and bread which is there in L2. So that's a tick. And then apple pie and cake even that is there, so that's a tick. But then comes bread and cake which is not there in the previous, which is L2. So it's infrequent. So obviously we can't go further with this because it's going to get more infrequent and infrequent in larger data sets. So what we do is we remove it here. We remove this set completely. So this helps us and this helps our time. It helps our computational energy. So and this is efficient. Yeah, this is another example like total transactions. Uh, in the code we are going to do it's something like this, like the input has to be done like number of transactions 5, then minimum percentage for support will be asked, minimum confidence will be asked 60, then we're going to enter the transaction for each new line, and we'll do this. We'll look into the code. uh, right, so let's dive into the code now. Okay, okay. Yeah, so this is the basic C++ code. Let me just zoom it. Right. So these are the basic header files required for coding this. And these are just basic aliases I've done for better readability, and items that has been done into the set because to maintain its uniqueness and transactions to for us to take care and support map. These are the basic things. And we made a basic subfunction, a void function to print the item set, like if there are milk and if a person is buying milk and bread, then if he's going to buy butter with certain whatever the confidence percentage is going to be there. Uh, this is going to be the code. We are doing an outer function and we're doing beginning this just basic coding, and we are doing pointer iterators, right? Okay, so this is the main sub function which you are going to look into. uh right, so this is a set of the item set. Okay. What this does is, as I told you, the terms L1, L2, L3 for convenience, the same thing has been done here, and subfunction has been named generate candidates. This does nothing but it generates item sets of size k by combining the elements in lk minus 1, which we just discussed through the example, right? So first we are going to define k, which is going to be lk minus 1, number of terms in plus 1, right? Uh, all right. So first, what we're doing is first we have defined k, right? Now next we write a loop. We write a loop in which it starts from the first term of lk minus 1 and it just merges those terms as we discussed those sets. It merges and then checks for the subsets. Okay. Uh, so here we have started the loop from begin to end. Then we've gone into the next one, and we've gone into the next one, and now we're combining it. This part we are combining the item set. Okay. So now that we have combined the first and second, and we have done a loop for it, the sets are going to get combined. Now, here comes the pruning step. So what we are going to do here is we are going to check the items like the previous LK minus one sets, and we're going to remove it if it is not frequent. How do we know it's not frequent? We just verify if the items which we just made by combining, like let's call it LK, because if we combining it, it forms of size K, so let's call it LK. So if the subsets of LK are present in LK minus 1, so it obviously means that it's frequent, so it's going to go forward. But if the subsets of LK are not there in LK minus 1, we are obviously going to remove it there and there to reduce the number of calculations we're doing, and keep it totally easy and efficient. Again, I'm mentioning, wherever I mention subset, I just mean that suppose there is a element set of 5. I just mean that the number of element sets 4. I don't mean each and every subset, okay? Because it's obviously going to again check things again and again, so it's just a waste of time or waste of energy of this energy, waste of efficiency, if I should be more precise. Okay. So this is the pruning step. If the subsets are frequent, which we coded before, it's going to take us through, and it's going to the code is going to run further. But if the item set here's the main if loop, if we don't find it in the if we don't find it in the LK minus one, which we have verified here, we have written false. So the code will break here itself, which means the code is not going to go further for that respective subset. It's going to stop there itself. So this is the main pruning step of the a priori algorithm. Right. Next, after that, we just insert the whatever has passed, because here itself the code is passing, and it will skip this for loop if it is if all subset frequent is true, and it's going to go here, and it's going to get inserted, and the candidates will get returned, right? Now, after all this a priori algorithm and stuff, we are going to dive into the main function. Let's get into the main function. So first, what we do in the main function is, let's read first. We need to read the input. So we are going to define this num transactions, which is going to be the number of transactions that we are going to take in, and double support and confidence, because it can be less used to. Okay, and this is just basic C out C and just to input the data. Excuse me, just to input the data, and this is again a for loop to take in according to the number of transactions. This is just a for loop which is going to take in the each data, like butter, bread, egg, then coffee, tea in the next line. So number of according to that, like if there are 5 lines, it's going to take 5 lines of transactions according to the data that we're going to type in, right? Now this is the code which is going to do the first step which we just discussed, right? It's what it's going to do is that for each object, it will check if the support data has been met or not, and just applied seal for decimal things, and that's it. And we're going further, and we're checking it for each and every item. It's just for loops for that. We're checking for each and every item whether if the support has been met or not. Then here comes the for loop. Right, here comes the for loop, and here we used most of the like functions which we defined before, right? These sub functions like generate candidates, and I think print item set is used later while output. Yeah, mainly this one, generate candidates has been used here. Right here it has been used. So basically, yeah, what that's what it does. It's just going to combine, then check the subsets, and it's going to check the support rate for that, and it's going to prune for whichever this support has not been met. So yeah, that's what this basically does. It's just this is just a for loop from the L2, L3 that we have defined before. We already generated the candidates. It's just going to take those candidates which you have returned in the respective sub function. It's going to return the candidates, and for each and every candidate, this is going to check whether the support percentage has been met or not. That's which this for loop is for, because this is a if condition, because if it's more than the minimum support count, then only it proceeds further. Right. Now the a priori part is done. A priori algorithm part is done. Now we go into generating and printing the rules for the supermarket owner for him to be for this data to be readable easily. For the transaction data that we have taken in, we're going to make it easily readable by making just certain association rules. So here we have minimum confidence. Of, by the minimum confidence, we just need the percentage. So because while doing input, the percentage would be a lot more helpful than the example that we've seen before, in which it was given two. Because for different items, it can be a different thing. Because like if a person buys a number of chocolates, and if he buys like milk too, like number of milk packets. We can't set the support two for the chocolates as well, and two for the milk as well, because the milk is a larger quantity and the number of packets of milk sold is going to be obviously lesser. So we're going to set a percentage, just basic. And here we're going to generate subsets. And first, let me tell you what is consequent and antecedent, right? So antecedent, what is so antecedent is nothing but basically like when we give the output, we tell if a person buys bread, there's this much percentage, otherwise this is obvious that he's going to buy milk. So in this data, the bread is going to be the antecedent, and due to this antecedent, the data from the data that we've calculated, milk is going to be the consequent. So this is going to generate there's the subsets for the output, and here we have this confidence. If the after that we calculate the confidence here. Here it is. The confidence has to be the minimum confidence has to be given for by the user or the supermarket owner or whosoever is going to use this, and we are going to do the here we have defined confidence for each item set. And if the confidence is more than or equal to minimum confidence, then we are going to print that item set and consequent, only then it gets passed through, and it is going to get printed. So now that the code is done and we have discussed an a priori algorithm, now finally let's test our code, right? So okay, so here it is. Okay, just let me clear this terminal first. Okay, so here we have. Okay, so first, in this code here we have already. Let me show you. Okay, when we initialize the main function, we have written here. Please enter the number of transaction desired. Plus, yeah, I did it, and it's just asking. Let us keep it. What do we keep? 5. Right. Now, as you've written here, he is also asking the minimum support percentage data. Let us keep it. Let's keep it. Let us keep it 40 as he has given in the example, because 40 is just an example. And even this he has given, we have written 40, I mean 60. So let's just do 60 because it's just an example, not something complicated. Right. Now here came this loop, which I just told you. Yeah, this is the transaction input loop. We are taking strings, obviously. So let's do a sample input. Let us say one like the first person buys milk, bread, and butter. Okay. Now let us say the second person takes milk and bread. Okay. Now let us assume the third person takes milk and butter. Now let us say the third person takes bread and Nutella. Uh, Again, milk, bread, Nutella. Okay, this is just a very small data that we have done, just for an example. Now let's run this code. Okay, so here we have, uh, okay, so here we have, this clearly tells us if a person takes bread, if a person takes bread, there's 75% confidence chance that he might take milk. And here we also have how many times he has to consume milk, bread, milk, bread, milk, bread. And similarly, if a person takes milk, he might take bread, which is 75%. In this example, we got this both equal, but it might not be equal because a person who takes bread always might not take uh, bread. Otherwise, a person who takes bread might always not take milk. So it varies. And here we have if a person takes Nutella, he's 100% taking bread. And if a person is buying butter, there's 100% that he or she might buy milk. So this was the basic idea behind the project, and this is just a this is just a basic form of what is used in uh, recommendation systems. And if you work on it further, maybe find it. And these are the several uses. Let me just go back to the presentation. Uh, ah, right. So here the same thing we did based on three instances. Here the milk, the same thing. This we completed the whole code. And yeah, we have the implementation is obviously uh, in a very large requirement in the actual real world, and the output can be used by the businessman, otherwise whoever is going to use this for better marketing strategies that he or she has to develop. And this was the basically my CWS project, and that's it. Thank you.